And for the Butterworth filter, so you should remember these notations: alpha p, alpha s, omega p, and omega s for attenuation and band frequencies, pass band and stop band frequencies. So here in the Butterworth filter, first we have to design the analog Butterworth filter. In the case, we have to derive the equation for h of s. After that, only using any one of the method described here, bilinear, impulse, or backward difference method, we have to convert the h of s into h of sz. So for designing the Butterworth filter, first we have to go for the order calculation. And here the n have the different meaning. N, capital N, is the order of the filter. So using this formula, we can able to calculate the order of the filter. And if you are having our n, right, the 2 point something, likewise if you are having, then the next step is, after calculating the order n, we have to round it to the next highest integer, right? Then we have to go for that, right? That will be the capital N value, and we have to write our h of s equation. H of s equation is, in the denominator portion we will have, depending upon the order of the n, we will have the equation right over here. We have to select from this table, but always the numerator value will be equal to 1. H of s equation, in the h of s for the designing of the Butterworth filter, that too in the low pass Butterworth filter, the numerator value of h of s will be equal to 1 always, and the denominator of h of s value will be taken from this table. Suppose if your n value is equal to 1, then my h of s value is equal to 1 divided by s plus 1. And if it is equal to 3, n order is equal to 3, then my h of s value is equal to 1 divided by s plus 1 into s square plus s plus 1. In this way, we have to do our h of s calculation. And for the Chebyshev filter, again the order calculation n, and then round it to the next highest number. And here it is a little bit complicated procedure here, and you have to calculate the epsilon value and mu value using this formula. First we have to calculate the epsilon value, and with this epsilon we have to calculate the mu value, and with this mu value we have to calculate our a and b values, right? And here the location, sk value, right? Sk is equal to a into cos pi k, so here it is pi suffix k, plus j into b sine phi suffix k. And here the pi suffix k, how will you calculate? Pi by 2 plus 2k minus 1 into pi divided by 2n. Here this capital N is the order, right? After rounding, what the value we have, that is substituted here. And here the k value will ranges from 1 to n, order n, right? 1 to n, order n. Right, after calculating this, all these things, and you have to write your s value, that is s minus h of s, right? So s minus s1 into s minus s2 into s minus s3. Likewise we have to write our equation for the denominator portion, right? And for the numerator portion, you have to depending upon the value of order n, whether it's the odd number or even number. If it is odd number, then we have to substitute s is equal to 0 in our denominator portion, and then calculate our value. That will give you your numerator portion. If it is even, then we have to substitute your s is equal to 0, and then you have to substitute your value here, epsilon value, and then we have to find our numerator portion, and then finally we have to write our numerator. H of s is equal to numerator divided by denominator in the Chebyshev filter. And the frequency transformation in analog domain, that is here, these equations are used to calculate for low pass filter calculation.